Okay, everybody, this is Unit 1, Day 8. All right, some of you, for most of you, I believe, we have gone through all these problems, but I just thought I'd give you guys a reference and have something you can always look back on. So anyway, all right, let's get started. So here's our basic steps when we are adding and subtracting rationals. Okay, so in the first example, okay, this looks like it's just a fraction here. Okay, so what do we know about fractions? Well, we need a common denominator. Okay, so more importantly, least common multiple. Okay, that's what that stands for, least common multiple. Okay, so in this case, right now we could multiply the 6 and the 15. All right, that would give us 90, and we could use 90 for a denominator. Okay, so that always works, guys. If you're when in doubt, all right, just multiply the two things on the bottom here. Okay, and that will always give you a common denominator. All right, you might have to do some simplifications at the end. Okay, but you'll still get the same answer. Okay, so I'm going to do it both ways just so you guys can see what I'm talking about. All right, so if I did 6 times 15, well, that means I got to multiply the top and the bottom by 15. So that gives that 75. Over here, I'm multiplying the top and the bottom by 6. So I get a 12. 75 plus 12 is, 87. All right, and 87 is divisible by 3. Again, use the 3 trick. All right, 8 plus 7 is 15. That's divisible by 3. 90 is certainly divisible by 3. Right, 9 plus 0. All right, so therefore, both of those can be divided by 3. And so the top one is 29, and this one is 30. Okay, that is if we didn't use the least common multiple. We still get the same answer. We just have to do some simplifications at the end. All right, our least common multiple in this particular case, though, would be 30. Okay, and if you're wondering how I came up with that, well, there's a way you could do that. You could go 6, 12, 18, 24, 30, 36, 42. Okay, and then for 15, you go 15, 30, 45, 60, and you want to look for whatever number they have in common comes first. In this case, it is 30. Okay, so you can use that trick as well, but it might not be so helpful when we do rationals. So anyway, here, to get to 30, I had to multiply by 5, so I got to multiply the top by 5. 5 times 5 is 25. Over here, I had to multiply the bottom by 2 to get to 30. So I'm going to multiply the top by 2, so I get 4. And lo and behold, what do I get? 29 over 30. So both methods work the same. Okay, I prefer this one just because it's less steps and it involves a little intuition as far as your multiplication table. Let's look at example 2. All right, in this case, we have an x in the bottom. All right, so let's first think about these two numbers right here. We'll worry about the x in a second. All right, so to get this common denominator that we need so bad in order to subtract these things, okay, I'm going to multiply 3 and 7 because they're prime numbers. Neither one of them have a factor, or neither one of them are factors of one another. And I just know that 21 is probably going to be the least common multiple here. Okay, so 21 is going to be the pick. And then now I just attach that x on the end, okay, because we already had an x here. All right, so because both sides had an x, that just stays. And so now I just got to multiply this by 3, multiply this side by 7, right? And so over here I had a negative 12, over here I got a 35, and now I go negative 12 minus 35, right? This negative stays with that 35 there, over 21x will give us a grand total of negative 47 over 21x. Okay, hold on a second. There's music out there. Okay, sorry about that, guys. It's driving me nuts out there. All right, so that's example 2. All right, let's go down to example 3. So for example 3, all right, in order to find my common denominator, basically, in this case, neither one of these are a factor of each other, all right? They are, not even the same variable, all right? So the only option we have in order to find a common denominator is to multiply those two pieces together. So x times y and x times y. Now, we have to think about, okay, how did I get that? Well, I had to multiply the left expression, top and the bottom, by y. And then over here, multiply the top and the bottom by x. And so we're left with y plus x over xy. Now make sure we don't cancel anything here, okay? We're leaving this as is. We cannot cancel anything in the top or the bottom, okay? Because we have a addition sign between the y and the x, okay? So that's a whole expression. It's some number, and so therefore don't try to cancel anything. That is our answer there. Let's take a look at number 4. Okay, number 4. All right, and this one, all right, you can't add anything or subtract anything to a denominator. We can only multiply. So in this case, again, just like example 3, the only nice way to come up with a common denominator here is we're going to have to multiply these two things together. All right, and so let's do that. So we're going to have a denominator of x over x plus 2, and then x plus 2. Okay, and so over here I had to multiply the top and the bottom by an x, so I get a 4x. Over here I have to multiply x plus 2, x plus 2. All right, so I get an x plus 2 in the top. And now let's put things together. So I get 4x minus, now we're minusing that whole piece right there, right? Remember, this is some number. We can't just separate things when we feel like it, all right? That is some number if we, obviously had an x. So we have to, I'm putting that thing in parentheses and you'll see what I mean here. All right, so why I put that in parentheses is because we're going to have to distribute that negative sign. All right, we're going to have to negate everything inside that parenthesis. All right, so 4x minus 2 all over x plus 2. Let's combine some terms here. So we're going to have 3x minus 2 over x times x plus 2. And that is our answer. Okay. Let's keep going. All right, so down here, all right, I'm going to slip a 1 under that x so that we have 1 over x minus x over 1. Okay, don't try to cancel anything. Can't do anything there yet. All right, but our common denominator, in this case, has to be an x. Okay, that's the only thing that those two things have in common, or that's the only common denominator that we'd be able to come up with, especially if we just multiply those two denominators. So on the left side, we keep the 1 over x because we didn't have to change anything. I liked the denominator. I liked where it was going. Okay, and so the only thing we had to change is I had to multiply the top and the bottom on the right side by x. So x times x is x squared. And so now we're left with 1 minus x squared all over x. And finally, this is a difference of two squares. So this is 1 minus x, 1 plus x, all over x. Remember, this is a DOTS, okay? I know sometimes you don't recognize it when it's a 1, but you got to remember 1 is a perfect square, right? What's 1 squared? Well, it's just 1 times 1, which just gives you 1, okay? So it's one of those things that students tend to forget. So just remember, when you see something like this, these are difference of two squares. Okay. Let's look at number 6. So number 6, okay, this is a beast, all right, or at least more beastly than what we've seen thus far. So let's take a look at these numbers here first, okay? So 18 and 27. Now I could multiply those together, right? And so by doing so, we would get 18 times 27, which is, whoops, 486. So we could have a common denominator of 486, okay, with the x's, hold on to these guys right here, okay, we're not going to talk about those yet, we're just talking about the numbers, all right. 486 seems really, really huge, okay, so I'm going to use the least common multiple here, all right, because I don't need a number that big. I just want, you know, something that these things both turn into, but relatively small, and that number is 54. I'm going to put the 54 there. Notice I'm giving myself some space. All right, and so over here, I'm going to have to multiply the top and the bottom by 3. Over here, it's going to be a 2. Whoops. All right, but notice I left a space there because there's going to be some things after that 2 and that 3. All right, so now let's focus on what we have in pink. All right, so in pink, we want to look at, okay, let's take a look at the x's. Okay, what's the largest exponent you see? All right, we see x to the third power. So therefore, we're going to use x to the third power, which means, all right, we're going to have to multiply this right side by 1x so that we'll have the same x cubed as we do here on the left. All right, now let's take a look at the y's. Okay, in this case over here, our largest y is 3. All right, y cubed. So we're going to use y cubed. Right? You want to incorporate the largest exponent you see. All right, and then on the left side, I'm going to have to multiply to get from a y to a y cubed. I'm going to have to multiply by y squared. And finally, I got everything ready to rock and roll. 3y squared plus 2x. All right, and what's nice about those two things is we can't do anything with them. All right, we just put those next to each other. Write that common denominator underneath. Remember, the common denominator stays, and that's our answer. All right, and that is the conclusion of the video. All right, so for homework, I have assigned classes different homework problems, and I have that listed in your guys' assignments. Okay, so if you have any questions, bring those to me, please, and thank you.